one of the difficult things when trying to make a real cycle that is close to a Carnot cycle are the isothermal transformations, because usually when we use a heat exchanger, the transformation is isobaric, but not necessarily isothermal. So one way of doing this is using the specific properties of phase change, liquid vapor phase change, in pure fluids or in a mixture of fluids that are behaving like pure fluids. So let's represent the thermodynamic properties of pure fluids in a TS diagram. So T like temperature and little s like specific entropy. And when we have one pure fluid homogeneous at equilibrium, it is possible to describe its thermodynamic state only using two independent state variables. So that's what we are doing here. So first thing you can see in a TS diagram is the saturation curve. So schematically the shape of the saturation line looks like this. There's one specific point and this curve over there, that's the critical point. So the critical point is the point over which there's no difference between the vapor and the liquid, and so the saturation line is separating on the left hand side the liquid phase and on the right hand side the vapor phase. Inside the saturation curve, so that is below the saturation curve, this space is used to represent a mixture that are made of one fraction of liquid and one fraction of vapor, both of them being at equilibrium, so being saturated. So, for example, this point will consist into one fraction of saturated liquid in this state and saturated vapor in that state. Okay, so inside the bell, this is a mixture of liquid and vapor. So first thing we want to know is how much liquid and how much vapor we have when we have this point, and what is used in order to define this is what we call the vapor quality. So the vapor quality corresponds to the mass fraction of vapor. It's really usually written X, and this mass fraction corresponds to 0 on the liquid saturation line, to 1 on the vapor saturation line, and here we are somewhere in the middle, probably around 0.3 for the vapor quality. So each lines there are corresponding to an ISO line of constant vapor quality. So then, so on the x-axis we have the specific entropy, so we can just simply read the specific entropy. On the y-axis we have the temperature, so the isothermal lines are of course horizontal. T is equal to 0. Then what else do we want to read on this? Probably often the pressure. So the Isobaric Line, so the lines of constant pressure. First thing we can say is that for a pure fluid inside the saturation line, so I mean during phase change, the pressure is at constant temperature, so it's merging the isobaric line are merging with the iso temperature line inside the two-phase zone. Then on the liquid side, the isobaric line are almost merged with the liquid saturation curve. This is due to the fact that the liquid is not compressible, so these two lines are almost merged, and on the vapor zone, the isobaric line are going up like this, so that Cp is equal to 0. What else are we looking for? Probably the specific enthalpy. So the iso enthalpy line are going this way, and I usually indicate it in such diagrams. So that EH is equal to 0, lines of iso enthalpy. And this is a very useful diagram in order to describe what is happening and different transformations that might be happening in a pure fluid or in any mixture of fluid, like for example an azeotropic mixture that is behaving like a pure fluid.